Okay, welcome to my video tutorial on the periodic trends activity, the graphing activity, where you'll be making three different graphs um, based on atomic number versus atomic radius, atomic number versus first ionization energy, and atomic number versus electronegativity. So you are responsible for creating three different graphs, the first being with atomic radius, the second being ionization energy, and the third being electronegativity. I will walk you through the first graph, which is the atomic radius and atomic number, but you are responsible for your own graph of ionization energy and electronegativity. Um, so there are two charts here, but it just shows the first set of elements going up to element 20, which is calcium, and then a second set of elements going up to zirconium, which is atomic number 40. So there are 40 total points that you need to plot. And the materials that you'll need are graph paper, pencil, ruler, and your periodic table for your electronegativity values. So let's flip this over and look at the guidelines. So I'm going to just zoom in a little bit here. So using graph paper, a pencil, a ruler, prepare a full-page graph of atomic radius versus atomic number. Follow the graphing guidelines for scale, title, axis labels, etc. So in other words, make sure it's neat, make sure that your points are plotted correctly, make sure that you're choosing a reasonable axis, and make sure that your title is underlined and all of your axes are labeled. So this is what we're going to start with. So I have some graph paper, I have some graph paper under here. And you can choose whether you want your graph to be portrait or landscape. I find that for this activity, it's best to make sure that your paper is landscape because that gives us enough space to plot all 40 elements. If you're doing your graphs portrait-wise like this, there's not going to be enough space along the x-axis to plot all of your data points. All right, so let's start off by looking at our data. So we know we have to go up to 40 elements. So when we create the scale, we want to make sure that we have enough space for all 40 elements. So let's go across the bottom and see how many spaces there are across the bottom of our graph. We want the x-axis to be at the bottom, and that's going to be our independent variable, which in this case is the atomic number. So let me move this up so you can see it. So I'm just counting the number of spaces that there are at the bottom here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. Okay, so we have more than enough space for if we want every one spot to be one new atomic number, but we don't want to leave too much space over here for our x-axis, or sorry, for the y-axis, because we want to make sure we have 40 squares going across the bottom here. So let's put our x-axis in and we can start labeling the points there. And I want to leave enough space so that I have enough space at the bottom for both labeling my numbers as well as a title. So I'm actually going to move this up one just to make sure I have enough space here. Okay, there we go. Make sure you have a sharp pencil because if you don't have a sharp pencil, you're not going to be able to plot your data points very well. All right, so there's my x-axis. Let's put in a y-axis as well. I don't know what my y-axis is going to be yet. I'll have to look at my data first and see what the range looks like. But I can go ahead and label my x-axis. So I'm going to label every 2 squares just so it's not too crowded. So even though I'm going up by 1 each time, I'm only going to label every other square. Again, that's just to make sure it's not too crowded. So all of your graphs, because your x-axis is going to be the same for all of them, you can use the same scale each time for your x-axis. Am I counting this correctly? 2, 4, 6, 8, 10, 12, 20, 22, 24, 26, 28, 30. Make sure you're not accidentally doing one here or doing one here. Make sure that it's like properly spaced out. Okay, so now that I have my scale, I'm going to write my label in. This is atomic number. I'm just referring to these data points are going to be these x data points. So atomic number is going to go at the bottom here. And once again, atomic number will be the x-axis for all of your graphs. Atomic number. Okay. Now, before I decide on a label for the side, I want to look at what my data is. So I'm going to zoom in here. So atomic radius, that's basically the size of the atom. So I should expect my smallest ones to be over here. So hydrogen's atomic radius is 32 pm is picometers, so 32 picometers. And the largest, let's see, got 235. Is there anything higher than 235? Yes, rubidium is 248. So I need to make my scale go up to 248. So let's see, what kind of scale will we be working with here? So if we go up by 5s on the left, so if every square is 5, then we can do, and I'm just going to count it just to see. So 5, 10, 15, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay, so I do not have nearly enough space to go up by every 5. So let's try going up for a square is 10. So instead of it being a square is 5, I'll do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50. So that's 150, 160, 70, 80, 90, 100. That would be 200. 10, 20, 30, 40, 50. Okay, perfect. So my data can go from 0 to 148. So my last point is 248. And my last point on my graph was 250. So it's actually perfect. So let's go ahead and label every 50. So this will be 50, 100, 150. Let me just double check that all these are right. That's 5 squares, 5 squares. Yes, yes, okay. 200 and 250. And I want to make sure that I have a label at the side as well. So referring to this guy over here, it says atomic radii. Radii is a plural for radius. And I want to make sure I include the unit over here. So atomic radius. And it's measured in picometers, so I'm including the unit there. All right, so my 2 scales are done. Now I can go ahead and plot my points. I'm gonna wait till the end to give this a full title, just so that I don't write it too low and then get in the way of my data points. So before I plot, let's see. It says prepare full page graph for atomic radius versus atomic number. Use the graphing guidance. Okay, so just go ahead and graph, it seems like. So let's see. 1 and 32. So atomic number 1, 32, so 10, 20, 30, 35, so less than 35, we'll say around here. This is why you need to have a sharp pencil. You don't want your points to be too large. The next data point, so I've done this. My next one will be helium. So helium is atomic number 2, and 93. So 50, 60. Okay, so 93 is probably right around here. Okay. Lithium, atomic number 3 is 155. Okay. Beryllium is 4 and 112. So you can go ahead and skip this part of the video. I might just go ahead and plot this separately so that you can jump ahead. Oh, I plotted that one wrong. To make sure it's erased well, that's, because otherwise it's going to get confusing. Oxygen is having 3. Okay, now I'm going to use my ruler to find 190 on here. So this is 200 up here, so 190 is right here. 60. Let's erase that. It looks like there's 2 points there. There should just be 1 point.